In this teardown, we're taking apart the UGREEN 160-watt power display, 4 USB-C and 1 USB-A GaN charger. It delivers a total output of 160 watts. It provides smart power distribution across 5 ports in a compact body. The color LCD shows power, voltage, current, and charging protocol status in real time. The box includes the charger, a 240 watts braided fast charging cable, and a user manual. The cable has a built-in Richtek e-marker chip. It supports PD 3.1 power delivery at up to 240 watts. The charger features a space silver metallic finish. It uses a square design with rounded corners. It comes with foldable Chinese standard prongs. The front features a color LCD and a touch-sensitive button. You can switch between total power, per-port power distribution, voltage, current, and other information. The charging status is easy to see at a glance. The charger measures about 75.66 millimeters in length. The width is about 75.77 millimeters. And the thickness is about 35.86 millimeters. The charger itself weighs about 330 grams. It uses a 5-port, including 4 USB-C and 1 USB-A output configuration. The USB-C 1 and USB-C 2 ports support PD 3.2, PPS, and AVS. They also support all major protocols, including QC, SCP, and FCP. They cover voltage levels from 5 volts to 28 volts. The USB-C 3 port supports PD 3.0 with up to 100 watts. The USB-C 4 and USB-A ports support standard fast charging protocols. It offers broad compatibility. Once we open the housing, the entire internal PCBA module is filled with gray thermal potting compound. A full-size aluminum heat dissipation plate is installed on the back. It uses a stacked modular PCB design. This provides excellent space efficiency and structural strength. At its core, the charger uses a PFC plus AHB switching power supply architecture. The PFC boost end is controlled by the Richtek RT7333 controller. It can directly drive GaN devices. This improves conversion efficiency and simplifies the surrounding circuitry. It is paired with an Innoscience ISG6106QA GaN power chip. The chip includes multiple built-in protection features. It balances high efficiency with high reliability. The PFC diode uses an M-Semitech silicon carbide device. This further reduces conduction loss. The AHB primary side uses the Richtek RT7795 resonant controller. Its resonant operating mode effectively reduces switching loss. It is paired with 2 Innoscience INN700DA190B discrete GaN MOSFETs. They feature a 700-volt rating and low on resistance. This makes them well suited for high-frequency, high-efficiency topologies. The high-voltage filter capacitors are supplied by Caution. TRX SMD Y capacitors and an Everlight EL1018 optocoupler are installed between the primary and secondary sides. They provide safe electrical isolation and voltage feedback. The synchronous rectification end uses the Richtek RT7220E controller. It is specifically optimized for AHB topologies. The output filter uses barrel and Caution electrolytic capacitors. This helps reduce output ripple. All secondary side buck conversion and protocol control use iSmartWare solutions. The USB-C 1 and USB-C 2 ports each use an iSmartWare SW3566H chip. It integrates a synchronous buck controller and the physical layer for a full range of fast charging protocols. The USB-C 3 port and the USB-C 4/USB-A port group each use an iSmartWare SW3536 chip. This is also a highly integrated dual-port fast-charging SoC. The matching buck MOSFETs and V-bus MOSFETs come from multiple Caution solid capacitors are used at the output to further improve filtering. The display PCB uses a Synwit SWM221 display driver MCU. It handles the display logic and touch interaction. This UGREEN 160-watt GaN charger uses a proven PFC plus AHB resonant architecture inside. It combines Innoscience GaN devices with Richtek controllers and iSmartWare protocol chips. All key components come from leading brands in the industry. Its 5-port, full protocol setup supports simultaneous fast charging for multiple devices. The LCD power display improves the overall user experience. The combination of potting compound and a metal heat dissipation plate helps maintain temperature control and reliability under high power output.